Hello everyone, today we are going to talk about systems of inequalities. We're going to start with inequalities about two variables. So far guys, you knew how to solve inequalities like this. For example, x plus 3 greater than 5. That's a typical linear inequality, right? Which is going to be solved by subtracting 3 from both sides, and that's x greater than 2. You draw a number line, draw over here 2, and greater than 2 is on the right of 2, right? And you are going to write down your solution as 2 to positive infinity. Now, guys, what is going to happen if we have two variables in our inequality? Example, two variables. That was one variable. One variable, only x was it. Variable, right? Two variables. Well, two variables can be something like this. 2 plus x is greater or equal than y. And how do we solve inequalities like this? Well, what are we going to do, guys? First, we are going to, you see that this inequality has both x and y, right? So basically, if you draw a number plane like with coordinates x and y, there are going to be some points here which are satisfying this inequality and some points which are not satisfying. I'm going to show you one example, or two examples actually. Let's consider point 3, 1. Does it fit into this inequality? We'll just plug it in. So 2 plus 3 is greater or equal than 1. Is it true? Is it true? Well, 5 greater than 1, so it's true. So the point is good for inequality. Now, how about the point with coordinates? Let's choose a point over here. Coordinates are -2 and 4. So 2 minus 2 greater or equal than 4. Is it true? 2 minus 2 is 0, obviously, right? It's not greater than 4. So this point is actually bad, and I'm going to make it black. So green points are good, black points are bad, but we cannot check possibly all points on number plane, right? So we would prefer to have something like a criteria to separate them. How can we choose it? Guys, if you look at this inequality, we have an equal sign here, right? Why don't we try to kind of see how the points are going to look when they are equal? Because you see, this one does not have equal sign, but if we put equal sign here, then this point is going to make a boundary between points which are good and points which are bad. Good points here and bad points here. So why don't we find the boundary? Boundary is usually when equality actually happens, when x equals 2 over here, for example, or when 2 plus x equals y. What is this? Well, 2 plus x equals y is just a straight line, right? I mean, if you write it down like this, y equals x plus 2, you know it's a line y equals x shifted 2 units up. I'm going to graph it. That's going to be my line. Y equals 2 plus x. Supposed to actually go over here to -2, but that's okay. So this line is actually going to be boundary between good region and bad region. How do we know which one is good and which one is bad? Region 1 and region 2 over here. Well, we already know that from region 2, the point which has coordinates 2, 3 and 1, 3, 1 is good. So we're going to shade this region. This is called test point method, but we are not going to just test a point with x coordinate. We are going to test a point with both x and y coordinates, which are belonging to a certain region. How do we give the answer? Well, guys, fortunately, we give the answer just as a picture. So you draw the inequality boundary and shade the area which is going to solve inequality. That's typical way to solve inequality. Let's try more examples. Example number 2. That was linear inequality. Linear means that x and y both are in the first power. Let's try a non-linear inequality. For example, x squared plus y squared is less than 4. Well, to create a boundary, we are going to make equation x squared plus y squared equals 4. Again, that the fact that we don't have equal sign here is not changing the boundary. It's just changing the fact that we are not going to include the boundary. Remember, over here, if we eliminate this equal sign, we're not going to include 2. So boundary is not included, but it's still a boundary. Well, what is this? That's equation of a circle, right? I'm going to graph this circle. Circle with radius equals 2, right? Because this is radius square, and the center 0, 0. So let me graph this circle. Oh, sorry, accidentally. So it's 2, 2, that's y, and that's x. Okay, now circle divides number plane into 2 areas, inside of the circle and outside. Which area we are going to use? Again, use test point, any point from inside of the circle. If it works for inequality, all points are going to work. If it does not work, all points are not going to work. I'm going to use test point 0, 0. I'm going to plug it into inequality. So 0 square plus 0 square is less than 4. True. True means that the point over here works. I'm going to shade all the region inside. Now, guys, do we include the boundary? We do see that inequality is stricter less than 4, means that we are not going to include the boundary. And I'm going to kind of make a little, maybe, dashed boundary over here. Kind of not easy to do because my razor is too kind of fat, but I'll do my best. Dashed boundary. So we are including all the region inside of the circle, but we are not including the boundary. The boundary is not included. Okay, that's going to be a solution of that inequality. And when you don't include the boundary, you draw it as dashed line. Okay, let me label it boundary. Not included. Okay, something else, something a little bit more complicated. Example number 3. Let's consider parabola. Y greater than x squared. Well, if we do the boundary, it's y equals x squared, and this is just a standard parabola, right? I already know that the boundary is not supposed to be included because I don't have equal sign here. So I'm going to draw my standard parabola with dashed line, just to not make dashed line after. Guys, don't forget to label your units and your origin. So which region should be here? This region above the parabola or region below? Again, test one point. I'm going to test point, this one, for example. That point has coordinates 3 and y is 0. So let's plug in 3 and 0. So 0 for y and 3 for x. 3 squared. Was it true? No, that's not true. Not true. Because 0 is definitely not less than, not greater than 3 squared, which is 9, right? So this region is not going to work. I'm going to shade the region which is going to work. Guys, to make sure that it's actually correct, I suggest you to check one point from this region too. So I'm going to test this point, the point with coordinates 0 and 1. So 1 for y is greater than 0 squared, and that's true. Okay, so that's how we kind of solve inequality, and boundary is not included. Okay, now what is going to happen if we combine 2 inequalities together? Let's combine first 2 linear inequalities and then combine first 2 non-linear inequalities. This is non-linear, right? You see that x squared is not linear. And the circle was non-linear too. But the first one was linear. Everything was in the first power. Now we're going to combine 2 linear inequalities together and see how it's going to work, and then 2 non-linear. And see how it's going to work. So x plus y is greater or equal than 2, and 2x minus y is less or equal than 4. So I'm going to draw the boundary first. So it's x plus y equals 2, which means that y equals minus x, bringing x over here, plus 2. And for this one, it's 2x minus y less, no, not less, but equals 4, which means that y equals, if I bring y over here and 4 over here, 4 over here and y over here, that's gonna be 2x minus 4. I'm bringing y here and 4 here, like exchanging them. Now, guys, there are 2 straight lines, which I'm just going to graph. For the first line, no questions, right? It's just a bisector of a second and fourth quadrant shifted 2 units up. So it's negative x, something over here, right? Plus 2. I'm going to move it 2 units up. Because we have equal sign here, we are going to include the boundary. So I'm going to make the boundary solid. That's my first line, this one. Okay. Now for the second line, well, it's also not difficult to graph, but I'm going to graph it using 2 points. So I'm going to set up x equals 0, and then y is going to be negative 4. So for x equals 0, y is negative 4. Negative 4 happens over here, my first point. And I'm going to set up x equals 1, and then 1, 2 minus 4 is minus 2. So for x equals 1, it's minus 2. And I'm going to just draw a line through these 2 points. Something like this. Now, how many regions I have? I have like 4 regions. So like region number 1, region number 2, region number 3, and region number 4. Which regions do we choose? Maybe we choose 2 regions or maybe just 1. Again, we are going to use 1 test point for every region. Try to check point which is obviously belonging to the region. For example, I'm going to check this point. What is this? 1, 2, 3, 4, 5, 6, and over here is 2. So 0.62. Is it going to satisfy actually both inequalities? If it is, then I'm going to be happy. So for the first inequality, I have 6 plus 2 greater or equal than 2. Checks. And 6 multiplied by 2, 6x. 6 is x and 2, second. I'm checking the second equation. Minus y is equal to 2 less or equal than 4. This is 12 minus 2, which is like 10, right? 12 minus 2, less or equal than 4. No, doesn't check. So no. Okay, I'm going to change the color, make it green, and check 1 point from the top region. I'm going to check the point over here. Point has coordinates. A green point has coordinates 1, 2, 3, 4 in like y and 0 in x, right? X is equal to 0 and y equals to 4. Okay, the first inequality, 0 plus 4 greater or equal than 2. Yeah, that's correct. And 0 minus 4 less or equal than 4, also correct. So this one works. I'm going to shade it, the whole region. Well, next region I'm going to check is region 3. I'm going to check point, I don't know, this one, for example. The point has coordinates minus 2 and 0. So minus 2, 0. I'm going to plug it into my system. Minus 2 plus 0 greater or equal than 2. It's already wrong for the first equation, not correct. So no. And the last region I'm going to check. Which color should I use? I'm going to use gray. The last region is this region number 4. I don't know which point to check. Well, let's check point minus 2, 2. So the point has coordinates 2, minus 2. So I'm going to plug it into the first equation. First equation is going to be like 2 minus 2 greater or equal than 2. Well, that's 0 greater or equal than 2, not true. So no. And we have just one region which satisfies our inequality, and that's just the top one, region 2. Okay, yeah, kind of long way to do it, right? But it's not requiring any special knowledge. You just kind of check points. I'm going to consider one more example. Now I'm going to move to nonlinear inequalities. Nonlinear means that I'm going to consider a combination of a quadratic inequality and a linear inequality. So that's going to be example, I guess, number 4. X squared plus y squared is greater or equal than 1, and x is greater than y. Two inequalities, and one of them is nonlinear, quadratic, the first one, nonlinear. Well, again, you draw the boundary. Boundary for the first one is x squared plus y squared equals 1, circle with radius equals to 1, and this what x equals y. The boundary for the second one is a line, straight line. Oh, that's kind of, sorry guys, my drawing skills are not super good. Well, I'm going to use 1 unit like 2 squares so we can see stuff on the picture. Otherwise, it's going to be too small. It's going to be 1 unit. That's a circle, right? Guys, I'm going to actually apply a different method of finding the region which we need to use as a solution. I'm going to solve each inequality separately. For example, for first inequality, there are 2 regions, right? Outside of a circle and inside. Which one we are going to use? Well, let's check point 0, 0. 0 here plus 0 here greater than 1. So we are going to use a region outside of a circle. I'm going to color it in green. So that's just a solution of the top one. For the bottom one, that's a straight line. I'm going to graph it first. I'm going to graph it with dashed line because there is no equal sign. Now, for this one, I'm going to also solve it separately. I'm going to use a blue color and try to check 1 point for the second one. Well, which point? I don't know. I can check point, for example, over here. Second one. This point has coordinates 1, 0, right? So x equals 1 greater than 0. That's correct. So solution of the second inequality is this. All the region below the straight line. Now, because we want to solve both of them at the same time, we'll need to find the region which has intersection of both of them, like green lines and blue lines. And this intersection happens below the straight line and kind of below the circle. I'm going to surround it by a red color. Over here, over here, over here. So that's going to be our solution. You can do it this way too. Otherwise, if you don't like to do it this way, you can check all the regions. Here we are going to have 1 region outside of the circle, 1 inside, 1 inside, and 1 outside, 4 regions. Again, you can use test points, and test points are going to work perfectly good. I'm going to ask you to solve 1 problem on your own, and that's going to be it for this lecture. Example number 5, not example, self problem. Self, and you kind of can check solution in like after you finish solving. X greater or equals than 0, y greater or equals than 0, and x plus y is less or equals than 1. Not very complicated. I'm going to count to 5, but my suggestion, stop my video and do the problem on your own. Okay. Okay. So 1, 2, 3, 4, 5. Let me graph number lines for x-axis, y-axis. I'm going to label 1 here, 1 here. So guys, I'm going to start with my first inequality, x greater than 0. Where x greater than 0? Well, x greater than 0 is over here, right? So what I'm going to do, guys, I'm going to shade in green color everything where x greater than 0, and x greater than 0 for all this half plane over here, right? Next one, y greater than 0. Y greater than 0, it's positive y, right? I'm going to shade now positive y's. You see, I don't want to do the regions. I just want to kind of solve each inequality. And for the last one, unfortunately, I'll need to do the graph. So I'm going to make a boundary x plus y equals 1 from where y equals 1 minus x, or y equals minus x plus 1. Minus x is going to look like this, right? Plus 1 is going to go through 1. So I'm going to graph minus x plus 1. That's going to be the line. Well, because I have equal sign here, that's supposed to be a solid line. Solid line. Now, which region should I use, the top or the bottom? Well, I'm going to test point for just this solution for this one. Test point is going to be this one because it's in one of the regions, either in the bottom. This one in the bottom, you can use the top. This point is 0, 0, right? So 0 plus 0 is less or equals than 1. Yeah, that's true. So I'm going to shade this region now below this straight line. Now, guys, we'll need to find the region where all 3 colors are represented. And I'm going to maybe highlight it. So all 3 colors are represented inside of this little tiny triangle. over here. Just you see that's a green color here and red color and blue color. And all other regions have two colors. Here we have blue and green, red, and here we have green and red, and here we have green and blue. But no region has three colors, and we need all three. That's going to be the final solution. Final solution is actually going to be a triangle with vertices 0, 0, 0, 1, and 1, 0. Okay, that's all for today's lecture, and please do your homework for practice.